Okay, so yeah, the Professor Kudo provided us the very delicate introduction of the symposium. So, okay, so uh, we will move into the first session. The session one is the reporting the activity of the OLSP project. So my name is Shuichi Onami, the chair of the OLSP project. Unit leader of the RIKEN Information R&D and Strategy headquarters. In this session, so we have 40 minutes, and so we will provide the actual output of our OLSP the project. So let me introduce the OLSP project or this session. So the RIKEN Open Life Science Platform OLSP project. So and the objective of this project is written here, and you can see the same sentence in the web page of our project. So our project collect and integrate the life science data in multi-level from molecular to organism, and in multimodal with different type of the observation. And so we will enabling the prediction of elaborate status of cells and individual, and manipulation of them. So with the data-driven approaches based on big data analysis technology, including the machine learning and the artificial intelligence. That is the objective and goal of our project. And it starts at the 2019. Okay. So, and to achieve this goal, we are using these approaches. So we collect the imaging phenotypic and omics data of molecules, cells, and individuals that are being produced in RIKEN's life science centers with machine readable metadata added to it. Okay? And apply big data analysis method based on machine learning and artificial intelligence or others to them. And so we will develop the platform that provide optimized research navigation with the utilization of the open big data. And we aim to evolve our current research style by a new life science based on data-driven approaches. That is our approaches, and so you can see the schematics. That is, we have here all the life science research center in RIKEN. So we put together all the data from these centers, and the OLSP project integrates those data with the well-defined the metadata, and provide it to the not only ourselves but also the RIKEN's the high computational AI related activity in those center, the RCCS AIP and the ITEMs. And also we will collaborate with the Japan University or Research Institute in Japan and worldwide as well. And also we want to collaborate with the industry for such an activity. And then, so we will disseminate RIKEN's life science data to the world, and so facilitate the open life science. That is our strategy approaches. So to make it, so we have this organization. So we invite the representative of each life science research center, that is the leadership of the data science in each center, and to constitute the core members of the project. So you can see the face of the the core members from each of the life science research center. And so fortunately, we got the official MEX-based funding from the 2019, and so the RIKEN kind of launched the life science data sharing unit at the Information R&D Strategy Headquarters, and so this unit is officially running this project since 2020. Okay, so this is the organization, and so we have done so from 2019 to this year, the 5 years, we already kind of run the project. And so many of you, I think, know that the RIKEN is now moving into the next midterm plan period from the next April 2025. And this will be the 7 years midterm. So, and in this next the midterm, so RIKEN kind of set up the big project, the TORIP project, that is the Transforming Research Innovation Platform of RIKEN platforms. So this is the details can be seen at the web page, but so basic idea is to kind of integrate all the data or data resource from the RIKEN, and utilizing the all computational resource in RIKEN, and so kind of facilitate the analysis or research in RIKEN in a different level, and so kind of make the more kind of research towards the to solve the social or human problem. So that is the basic idea. So this is the schematics of the project. Here is the section of the data kind of acquisition and accumulation, integration, and the computation, and the AI, and so to utilize the new type of the computation, such as the quantum computing, something like that, to make this the cycle running. So it will accelerate the science in RIKEN. That is the idea of the trick. So, and as you can imagine, this is a very similar idea of the original OLSP project, that is a data-driven and AI machine learning-driven the facilitation of the science. So actually, the OLSP or Life Science Data Sharing Unit is considered to be one of the kind of important element of the TRIP project. So, and actually, so our unit is under our OLSP project continue to the next the midterm period, and we can expect us more. So that is the current situation. So, and so that is the summary of how we developed the current position. So, and so this is the time of the ending of the 5 years first TRIP project period, and the timing to move into the next stage. So in this symposium, so we will review and recap what we have been done, and then so discuss about the future and what we should do and we can do or something like that. Okay. So, and actually, so we have done many activities in OLSP. So that's so I cannot go into detail, but so several items. That is the integration of public database in RIKEN in several each centers, and integrate and share the limited, not open, limited shared data at each center, and promoting the international collaboration of database of data for each data type, and the creation of the research result out of this open science activity, and so education and human resource development for open science, and also the creation of the evaluation criteria for open science. So those are just an example of the item, but we have been done the item and to promote the open science in open life science in RIKEN. So today's symposium, so as I said, so we want to recap what have been done, and then to discuss about the perspective, future perspective. In the first session, so as Dr. Kudo already mentioned, that we will recap what we have done. So, and we will ask I will ask the core member of the OLSP to present and also then, so the second session, so we will provide some successful success case of the open science from the RIKEN life science and also the other field, like and then so then the session 3 we will discuss about the possibility of the expanding the OLSP, and then so we will have some discussion, open the panel discussion, and so we will kind of understand what have been done, and we will make it the good kind of start for the next midterm in this OLSP project. Okay, so this is my introduction, and so I want to ask the core member of the OLSP to make the report of what has been done. So I forget who is the first one. So Shimogori-san, okay, so sorry, there's, yeah, please, the Shimogori-san starts the presentation.
Thank you for giving me this opportunity to explain about the activity that we're having in RIKEN CBS. So I'm Tomomi Shimogori from Center for Brain Science, and I'm a deputy director and also the unit leader for the neuroinformatics unit. So today I'd like to introduce you the activity that we are doing in the neuroinformatics unit, which is about how we are generating the CBS repository system. So why we had to, decided to generate our own is, I hope everyone agree about this, is like we are dealing with neuroscience, and neuroscience actually using a lot more different terminology, especially like anatomy, and we have a lot of more different modality that we are using only for understand the brain, like a calcium imaging and also like connectomics, right? So based on that, we thought that, of course we are happy to work together, but on top of that, we had to actually generate something special that we can deal neuroscience. So that's the reason why we decided to generate this. So some of you maybe already heard my talk before, which is about that the CBS CBS repository system. So which is like this. So let me just go to the top page first. Okay, so this is how the top page looks like for the CBS data sharing platform, or we call it repository system. I hope you can see here, this is how much data we actually have, how many people using. It's really quite active. And within this sharing repository system, within CBS, we can actually share data quite easily. How we do that is like, this is actually my own, my lab, repository. You can see a log here, then which says like a CBS open. So you can choose a level, how much you want to open your data. So like in this case, my ferret in situ data is open to CBS. But of course, you can keep it only inside of the lab. or even like a different level, or you can even open to public. You can put the password on it. You can share it with your colleague. So your colleague is the only one who can access to your data. So this actually helps a lot to share the data which is not published or which is really fresh. And on top of that, what we have started to do is, when you publish the data on your publication, now it doesn't need to be secret, right? In that case, also, after the publication, these data are quite solid. You don't add that much on it. So in that case, you can actually ask NIU repository system, the search committee, that we can actually review whether you have enough metadata for your repository data, and we actually provide DOI. So you can put DOI on your paper, published paper, so all the data will be securely stored. So, and how to look at it is here just a list of those data which are already open to public. Of course, the letters are too small, you cannot see, but these are each papers which is already, the DOI is provided and it's really solid. And these are all the papers that is published. So now these are open to public. Okay, so this is very basic. Of course, there's a lot of, the function, like what kind of metadata you can provide in each data. We just try to keep everything in like a pull down menu, so people doesn't need to think about what's the correct word or terminology for a specific brain region. You can just pull it down and find it in there. And also like a different species and different terminology. That's also a little bit annoying, but it happens. So if you choose a species that you use for this experiment, different terminology will show up. So we just try to help everyone, to make easy access, easy using, and save everyone's time. So this is what the effort we made in this. So I want to introduce a little bit something newer is this. So sorry, there's only Japanese for this website. Sorry, Pero, but I know you can read it. But I'm going to explain about that. So CBS is now a part of the Brain Minds 2.0. So this is a national project which we actually had. Brain Minds 1.0 was actually started 2014. So we were the core member of this for 10 years. And we have a lot of database for like a Marmoset Institute database, Marmoset connectivity database, and so on. And we're going to use those database, but at the same time now, Brain Minds 2.0, we have a slightly different mission. So then we have to share our data very quickly, and also we have to generate like a so-called digital brain. So digital brain is a platform that we can actually predict something which you cannot do in real world. For instance, gene expression in human brain, you need to predict. If you want to see it, you have to kill this person and look inside of the brain, which you don't want to do. So this is the platform that we use called digital brain. So we throw data which obtained from animal, human is also animal, but not human animal, And then we actually use the template of human brain, and then we can predict like a gene expression, connectivity, and neuronal activity. But to do so, again, to generate the platform, we need to have lots of good animal data, and we need to share it. So in the BrainMind 2.0, currently we have 8 different individual institute. This one actually says 5, but we only built it for 5. We are increasing another 3 that we can actually share our data using CBS repository system. So this is the platform we are trying to generate now. There are already some who put the data in it. So in here, we can actually search their data using this common search platform. This is actually only from my lab, but you can, with different, word, you can find other people who what kind of data they put in there. So once again, with using this system, you can keep your data only in your lab, only in your institute, or share with this, or completely open to public. So this is what we are generating. So this just started. So there's not many data yet, but in future, when we get a lot of data, especially when there's those published, we can actually come to this website and find a lot of data from not only here, but also in other institute. Okay, so I think it's pretty much the time. So this is all the activity we've been working on. Onami-san, do we take question here, or we just keep going? Keep going. Okay, next speaker. Thank you.
So I'd like to, introduce the ontology working group activity of the this working groups. we organized some ontology working group in OLSP. That is start from the 2020. So promoting the interoperability of the lifetime RIKEN through data that RIKEN through the shared vocabulary. So shared vocabulary is a very important thing for the to make the interoperability of the different data set. So we conduct a survey on the usage and the demand for the shared vocabularies, and also examine the proposed actionable strategies to accelerate data interoperability for cross-domain integration in RIKEN. So this is the member of the working group, multiple people from the different centers in RIKEN. And this is an overview of the survey. You can see the, maybe you cannot see, but these are data set from the centers, BDL and BLC and IMS and the lab and the CBS in RIKEN centers. So there we have the many data sets from different centers. And this panel shows that, this orange shows the main topic of the biological topics, and also pale orange means metadata for the main topic. And this part shows that biological entity interested in the each data set. And in other words, that's the omics level. Gene and metabolome, transcriptome, metabolome, and also phenomena. And also, this shows the biological process. And also, we summarize the biological properties that is kind of the like a thing with the genotype and the phenotype. And also, we had the survey for the experimental procedure for the data production. So in this is summary. So overall, we have the rich variety of data sets, but the topics are relatively concentrated in its center, and also many data sets contains genes, but they are not interconnected due to the variation such as species difference. So we use many different species. So we need to connect these data from RIKEN. We need to introduce a public data to connect. So because we cannot we cannot connect the gene data directly, but indirectly we need to introduce public data. We can connect the data indirectly. So also log is very important and considered useful for linking RIKEN data, and demonstrates demonstrates the utility in disease research and other applications we expected. And for the candidate of the author data, we focus on the Onami that is developed in the SIB, which is available as a RDF. It's a strong candidate for the author data, we think. And fortunately, we collaborate with the celebrities through the RIKEN hackathon. So this is an example of the RIKEN BLC data using RDF. So we have the in RIKEN BLC mouse RDF graphs. So we have the mouse and related to the MGI genes, and MGI RDF graph provides a link to the MGI gene, to the MGI mouse genes, and the OMA RDF graph provides a mouse gene to the aerosol cluster to the human protein, and human genes and ensemble human genes. And this ensemble human genes can relate it to the disease, or something. So using this kind of the relationship, we can yeah, we think we can connect our data each other, and also they can be connected to the disease. So disease is a very important thing for the utility of the RIKEN data. So this is a very important. We think this is a very important relationship with our data set to the use case or something. And also, fortunately, we have already have the data integration platform or using the RDF data. So RIKEN metadatabase that is developed in 2016, and also using this we think we can easily relate our data. However, there's some problem on the RDF. So that is inconsistency of the URI. So that is a very main problem for the RDF. So for the gene data, for the NCBI gene, there are some variation of the NCBI gene URIs provided from different data sets. So we need to correct or exchange URIs between data sets, maybe. So to solve this problem, we think two approaches. One is collecting URI in the in the database directory, or another approach would be the convert the URI with a program and changing it dynamically. But fortunately, we are using the one platform for the data integration. A single system can be solved by the collecting the URI directly, maybe. And also, fortunately, we are using the date registration system for the RIKEN metadatabase. So we think collecting the URI during data registration is efficient way. And and also at the first time, we need to set the target should be limited. For example, genes, the species, the proteins, disease. So at the first time, we need to set the target and doing this correct URI for the limited target. And overview of the modification algorithm compression table for the modification target may be useful. So after correcting tabs with a tool like RDF Doctor, the conversion table will be reference to the correct any consistencies. So this is a report by the 4 members of the OLSP, me and Yamamoto. He is a member of the DBCRS, and Kushida-san and Kato-san. So they make some recommendation how to address the URL inconsistencies. This is some one report, and but we don't some correcting action yet. But this report provides some very good showing the way to solve this problem, we think. And also, development system of the OLSP website for the introduction to the RIKEN database is also very important thing we discussed. So the discussion made in 2023. So we discussed that we need some introduction system of our dataset for the researchers outside in RIKEN. So we actually we have the RIKEN metadatabase, and also we can introduce OMA for the data integration, and RIKEN metadatabase provide the API, and also we can use APIs developed in the DBCLs, and we can we thought we can develop something, simple system for the data introduction. So, but this is now ongoing plan for the development systems, OLSP website to offer the introduction of the RIKEN database. This system maybe so showing some different data set, and also showing some overview of the database and number of gene registration and how many of the related to diseases, and link to the original data set, and also so this system provides the links to another content explaining the database for the actually next talk Kasukawa will show the some introduction of the interview page for the each data set. So this system this program may a good guide for the RIKEN databases, we think. But we are now going with the development. So we already developed the system, but we are now installing the preparing metadata for the databases. And this system will be coming soon, next year or something. Yes, that is. Thank you very much for the attention.
Okay, next I'd like to explain the OLSP other OLSP activities, mainly OLSP research project and outreach. So I'm Takeya Kasukawa in RIKEN IMS and also RIH. So first, I'd like to introduce OLSP research project. So this OLSP research project is an open call for supporting the researches utilizing the open data or enhancing the usability of the research data. So the main target is non-PI researchers and technical staff in RIKEN. So this OLSP research project starts from fiscal year 2020, and every year we called. So the OLSP research project has two categories. One is a data publication type. It's not actual research. So this is the purpose of this category is, so if your project produces data, so and usually each researcher publish using this data, but not considering the reusability of this data. So now the OLSP research project supports for kind of enhancing this data for reusing by other projects, also outside of RIKEN or inside RIKEN, both. So then we are supporting such activities. And also, category 2 is research purpose is supporting the researches, especially for enhancing the open science or open data activities, like the development tools or kind of method or many activities. So the all project, so it's the term of the all project is 1 year. So we expect apply to other grants within RIKEN or outside of RIKEN, external ones. So based on these activities. So the characteristics of the OLSP activity, OLSP research project is so after accepted, awarded, so we assign the mentors from our unit or other RIKEN staffs to support what the awardees can discuss with these mentors for improving their research activities. And also, we want assign the enough and sufficient budget for this one. So sometimes, so if you if the researchers get budget and if the budget is remaining, sometimes he or she purchase not so necessary items. But so we request not to purchase such no necessary equipment or items. But and also if you need more money, so we can discuss and then we can assign the additional budget for your expanding your research or something. So OLSP research project start from fiscal year 2020. So we awarded every year 6 projects, 2 projects or something. Totally 13 projects are awarded. So then the one achievement, example of the one achievement is this one. So this is originally Kajiyama-san had image in situ data for zebrafish neuropeptide activities. So then she proposed to OLSP research project, then awarded. Then we collaborate with Kajiyama-san. Then now she can build the atlas for this neuropeptide gene expression data. Then now this is published from the one paper. Another project is LeftSS. So this is a project to construct a reference set for the transcription start site in human and mouse genomes. So then in this project, so the LeftSS set is expanded and also developed the new tools for LeftSS LD GWAS enrichment. So then now expanded. So then also we connected with the RIKEN metadatabase and also UCS Citron browser. So then the access count is a bit increased. So after the final update, so the access count is drastically increased. Of course, someone is this is maybe spam accesses, but gradually increasing. So next, sorry for time. So next is outreach activities. So now, as explained by the Masuya-san, so we built a new OLSP website. You can access this from this URL. So this OLSP website has a project news or open call information on the paper list, and also interview and RIKEN database guide pages. This is planning. It's just in preparation, so you can show. So later. So and then interview pages. So each PI joining the OLSP has a kind of the interview provides interview pages explaining their activities or their database or something. So now you can you can find this interview page from our top page of this OLSP website. And so now we are preparing the database guide pages. So already explained by Masuya-san, so I will skip. So and also we have several OLSP events, like the OLSP workshop. They are held every year. Sorry, this is only the internal ones, but so this is held. And also symposium is this symposium, OLSP symposium is this one. And also now we are planning kind of the external symposiums in fiscal year 2025. So one is it's Nihon Shinkeika Taikai. So we will have a symposium. So if you join this symposium, this conference, please join this symposium. Okay, that's all from me, my part. Thank you.
So we already running out of time, but I want to add something. So that's the one topic is the international collaboration. So so the objective of the international collaboration is promoting and expanding the international collaboration in various data types. So we are doing, and so this is why that is open science must be global in nature. So promotion in each data type is the most powerful driving force for the open science. So and because of that, so we are doing. So and so if there is an activity, so we just join and help them promoting. And if there is no activity in some specific data type, so we will start to activity in this specific data type. This is our strategy. And so we can learn from other data type. So and so especially for how to promote the international database collaboration with etc. So we can get it, and then so utilize other data types. So we integrate the other data type, and so this is the objective of this activity. So actually, so we participated as a core member in the development of the international collaborative network of DBs and the data repository, and also in the participate in the discussion among the international community on creating international standard or various data vocabulary, ontology, and metadata. So those activities we have done, and we already published many the white paper of proposal. So I will show some example. This is the recommendation for the normalization of the metabolite nomenclature. So that's the metabolites described in different ways. So so Arita-san's group with together with the community proposed the normalization of the nomenclature of the metabolite. And this is our group. So we proposed the standardization of the data format and the repository in bioimaging data with the worldwide bioimaging community. And also we started the international collaboration project funded by the Horizon Europe. So this kind of activity. So this is just an example. So we have done many things in this activity. So in addition to the international collaboration, so one other activity is the development of the indicator of the to evaluate the open science activity. So this is a project we have to evaluate after the good or bad for the achievement of our activity. So, but there is no good activity to evaluate the activity of the open science. So we discuss with the community and try to build the evaluation the criteria. So so now we already prepare for the midterm the report and written in Japanese, but so we will be make it available until the end of this fiscal year. Okay, so very rush, but so this is just a example, but so we briefly show you the achievement of the OLSP project from the 2019. So roughly summarizing, that's we built the foundation of the RIKEN open life science. So we successfully built. I failed. So and so what next? So this is the, as I said, from the next April. So we will move into the next midterm. So we will maybe advance our activity by tightly collaborate with the TRIP project in RIKEN, and also tightly collaborate with the Japanese community and the worldwide community. Okay, so and we want to transform the way of science into the different one, the new one. So this is the aim and so hope. So this is the last slide from us. So and we already running out of time, but if you have quick question, please, any of the speakers, please make it. And but we have a discussion time later on or in the party, so you can do it. But if you have some brief comment to Piero. So.
Yeah, one of the challenges is there are many labs at RIKEN, and then they produce a lot of data. And traditionally, many PIs understand that the data is their own data, and they're not really preparing very much to really spread them. So, how is the conversation? What are the challenges?
Yeah, that's as you know, a very difficult question. So so basically we started at the TRIP project is I think a very good driving force, and the TRIP project itself provide some grant to the project. So we started with the data coming out from the TRIP project. So, and the TRIP project already funded to the many core facility in RIKEN. So, and together with the research DX team or TRIP-related activity, so we started to set up the mechanism to automatically capture the data from the facility with the metadata. So this is, I think, the starting point, and we also try to install the e-notebook system in it. So, and so, as you know, this is a bit different, but difficult, but maybe so we provide some good example and a good kind of practice in a specific the infrastructure or facility. Then, so the success of this activity will, I think, promote and kind of encourage the individual laboratory to use the e-notebook. This is one idea, but but still, it's not enough. Maybe so we can discuss more about that. So, okay, so sorry about the running out of time, but we want to get some break. So, yeah, this is the first, maybe so we get the 10 minutes break. So we will restart the session 2:05 in this club. So, and thank you very much for the attention. So, and please make a brief break. So, okay, thanks.